Okay, so the last time we left off at example 17, where we introduced conditional programming with a basic if statement that included the keyword if and else for an alternate path or flow of our program, which was all based on the result of the condition evaluated by the if statement. So what we're going to do now is we're going to create a new file called example 18, and this one will investigate the concept of an if statement without the else. So it's basically an if statement. If it's true, do this, else do nothing. So let's say we want to write a program similar to the previous one where maybe we evaluate if someone's age is above 18, then they can come in, else do nothing. All right, so we could do something like that. So we could say something like this, int age, okay? Then we'll ask the user, cout, enter your age, okay? And then we could do something like this, cin, and then that will be stored in age. And then we can have simply an if statement, if age greater than 18, if you want to include 18, you will do something like this. If it's simply greater than 18 but does not include 18, then it will be something like this. Okay? If that is true, then cout, you may come in. All right, so this could be a bar or something like that where only 18 and over are allowed to come in. All right, so let's see how this behaves. We can change this to evaluate passwords if you want. So we could do something like this, compile and run. Okay, this is the first time it's running, so let's change its properties a little bit. Let's put 36, there you go. All right, so it's going to enter age. So let's say you were 12 years old. What's going to happen? It's going to simply press any key to continue. So it will skip the true block of the if statement. Why? Because the condition is false. All right? So can we run this program again and create a scenario where the condition is actually true? Okay? When can that happen? 19 is good, right? Anything above 18 will work. You may come in. Now, let's suppose you're exactly 18. So now let's watch the behavior of a strictly greater than. So if you're 18, there you have it. It's still not true. You have to be greater than 18, not equal. So this greater sign does not include 18, which means this statement here is false, which means what I have highlighted here will not be executed. That's the true block. And it will skip it. Now, can we put more than one statement under the true block? The answer is yes. Now, let's suppose you made a mistake and you did it this way. Cout, your first drink is on the house. Right? So let's say that's how they're marketing the actual saloon or the bar. So if you're, so that way they get you to pay for some more after that, right? Now, you would think just because I tabbed it that it's under the true part. Now, if you were testing this code and the condition was true, you wouldn't know that there is a logical problem. So let's prove that for a minute. So let's compile and run. And let's say indeed you're 20 years old, right? So 20, watch what happens. You may come in, your first drink is on the house, so everything looks just fine. Now let's suppose now we enter 15. So let me run it. Can you guess what would happen? So I'm going to type 15 before I hit enter. Take a moment and think what would happen. That is correct. It will skip that first line, but it will not skip the second cout statement. Why? Because the second cout statement is not part of the true block of the if statement. Let's look at it. Sure enough, it skipped the first line, which is automatically part of the true block. The second line is not. So how do you ensure that the second line is part of the true block? That's where the curly braces come in to delineate the true block, the beginning of it and the end of it. So you'll have to put a curly brace here, go to the end of this, and put another curly brace here. Line them up so you know this curly brace here is the start of the true block. This curly brace here is the end of the true block. Now these two statements are considered part of the true block, and both will be executed if the age is indeed over 18. So let's recompile and run this. Okay. So let's put a 20 again. So 20 shouldn't be a problem. We didn't have a problem with that. Now let's put 12 again. And none of these two lines should appear. Okay. And let's put 12, right? As you can see, it skips both lines and it goes straight to system pause, which brings up the press any key to continue signal on the console. So if we do that, it ends the program. Okay. So that gives you an idea now how to write an if statement without an else. Okay. Let's do another example. And let me just, this time we're going to combine statements. We're gonna make sure that it's not just based on one condition. It could be a combination of conditions, right? So what I'm going to do is just copy all of this for a second, and then just gut it. Create a new program. This way, so I don't have to retype everything. Paste everything here, and then just gut it. Make this one a 19. Write down what you want to do without an else. But this time we're going to be combining logical statements to be evaluated. All right? So we're going to have to change this scenario of what we want to do right here. So we're going to have to think of something we want to do with this program. Maybe a password and a username. Okay? So both have to be correct for this to work. So the idea now, if you're going to do passwords and you're going to do usernames, you're going to have to think of something. How do you store a password and how do you store a username? Now, if it's within the code, right, that you already have a username and a password within the code, which we're going to be doing anyway, then it's fairly simple. You're going to compare a string to a string and then again a string to another. You could do something like that. The username and password typically will be on another drive or another file. That will be beyond the scope of what we're trying to teach today. But eventually, we will separate passwords and usernames and put them somewhere else, okay? So they're not going to be part of the code. That would be too easy to break in and hack passwords and usernames, right? So it's got to be a better way to do that. But right now, the point of this lesson is that we're going to compare strings. So for this one, we're going to compare strings, and if both are correct, then we can go ahead and do something. Now, how do you compare strings? So let's say you have string username and equals, so you can initialize the username to admin, right? So we have an administrator and string password equal PASSWD, right? So some of you are familiar with Unix or Linux, right? That would be the way you enter a password, right? It's not the password, it's the way you would enter it. So suppose I already have an administrator with the password username admin and password PSSSWD, right? But when you run the program, that's going to be hidden because it's part of the code, right? The user will simply see a message something like this. See out. Enter a username and password. Maybe something like this. And then we're going to have to see in some sort of a password. So these are these variables we're not going to modify. So we're going to need something, string, your username, and comma, your password. So we're going to need these two variables that you will fill in data in it. So your username, and then we're going to ask the user again, cout, enter your user password. And again, that would be seeing your password. One word. Okay, notice P is capitalized, user and N, U and N are capitalized. Make sure everything is fine. So right now, let me just compile and run this program. This will be example 19.cpp. So let me just first save it as example 19.cpp. Let's compile and run for a minute. Even though it's not going to let you in or not let you out or kick you out, we haven't set up any of that logic yet. So let's do that. But you could see it's asking for a username. You could type www and www. Nothing happens really right now because we haven't done anything to compare the username and the password to the actual username and passwords we already have in the code, right? So these will be the initialized default username and password for the administrator. And this here will be at runtime. So when you run this program, all they see is this part. They don't see this part. Not a really good way to do passwords and usernames, all right? But this is an example because we're going to need to compare a string to another one. Now, comparing strings is an interesting topic in C and C++. Okay? Some people might say something like, let's compare them like numbers, right? So you might see the equal sign to compare something. That's really because somehow, somewhere, somebody overloaded that operator. Overloaded means changed its meaning to automatically accept strings on either side, left or right. Now, the equality comparison is equal typically when you're comparing numbers. Let's see if it actually works with strings. So if, and we're going to say username. Let's start with username first. Equals your username. I'm just going to print here, cout, username match. Just to test it out for you, to show you what could happen here when you're comparing with the equal. Okay? So this will simply compare the usernames at this stage. Compile and run. Notice the compiler is not complaining that you are trying to compare strings, right? Be careful, that might not work in Java. So, if you're doing any other languages, the data type you're using, you may have to use a function to compare strings, right? There is a string compare function in C actually. Okay, but let's see what happens here. Let's say I actually type in admin as the username. So I got that correct. The password doesn't matter right now. So I do get username match. Let me run it again and type in the wrong username, right? So let me type Henry, for example, and 5555 for the password, and notice nothing happens. So it does pick up on the equality, at least for the username. Well, as a review, this is an if statement without an else. So that's pretty cool. Now we know we can compare two strings using the equal for this version of C++. So if we can do that, remember when you're logging in, both the username and password have to match. So what you're dealing now is with a combined logical statements to be evaluated. So we're going to combine this one with something else. So what are you going to combine it with? With this. And logically also you want the password to be equal to your password. So now what we're doing, so user match. So I'm not just going to say name, I'm just saying user match now. Right? So this is going to tell me that both conditions were true. Only if both conditions are true will I ever get user match. So let's try that. Compile and run. Okay. So let's say I do type in admin for the username, PASSWD for the password, and user match. Perfect. So now let's suppose I do type in admin but the wrong password. Let's see how this works. Run. And again, the correct username is admin. So let's say I get that correct, but I typed in the wrong password, right? So something like this. Notice I get no answer, which is perfect. The true block of the if statement does not execute. That's because you had you had at least one error, right? In some Unix systems, they do actually work that way. They're not going to tell you wrong password. They'll give you no message. You can't get in. So that way you wouldn't know if you've made a mistake with a username or password, right? So if you know the username and you know it exists in the database, that makes it at least halfway decent for hacking. So sometimes no news is good news. Don't tell them anything, right? So let's run this scenario where the actual admin username is wrong, me, like this, but the password is correct. And let's see what happens. Again, no message. No news is good news. That's exactly what you want, how you want this to behave. Now, there are different ways to rewrite this statement here, which is a combination of logical statements. If you want to make sure that it's very well understood what you're doing, put some more parentheses. Put one here, encapsulate every expression with the parentheses like this. Make sure this logically puts it into one chunk here. This here is a Boolean value. So does this one. This is the actual proper way to present it for clarity. If I don't have these parentheses, it will still work because the operator, what we call operator precedence, this takes over the equals. So it sees these in terms of hierarchy. This is highest, gets evaluated, then the left and right get evaluated that way. But just to lessen confusion, it's always a good idea if you have a simple expression encapsulated with parentheses, right? Great. So now you see how you can write a simple application that compares a username and a password, right? You can add more features to this where you need a third item. Say, just make sure, are you a robot? Yes, no. Okay. So if you want to do something like that, let's go ahead and modify that. So I will have a string robot equals no. And as long as you enter no, you're good, right? So are you a robot? Cout. Are you a robot? You can enter yes / no, lowercase. We can see that we can add more features to this. Cn robot. Okay, and then we're going to compare. We could do something like this. So we don't need it here. Oops. Let me just undo. I'm just going to change the logic a little bit. I don't need to initialize it to no. I just need the variable. And I'm going to compare it to an actual string right here. And robot equals no. Notice I can put the string right here to compare with. Right? So the string value that I want to compare with is right here. So all of this have to be true for you to have a user match. Well, let's go ahead and run this. Compile and run. Let's see, what did I do? Okay, I see the error here, so let me just remove this one right there. We're good. Excellent. So now, let's compile and run. And there you have it. So it's going to ask me, enter username. So let's go ahead and enter everything. Admin, PSSWD. So let's say and I say, no, I'm not a robot. User match. So now I've met all three conditions. Let's go ahead and make myself a robot with the username and password being correct. So admin, password, PASSWD. And yes, somehow I turned out to be a robot, so I can't come in. All right, so I hope you learned from this lesson that you can combine expressions, right here, with what we call the AND operator, and we will see as we move forward with conditional statements, other operators like the OR operator. When do we use the AND and when do we use the OR operators? Okay, so right now we saw a good example for using the AND operator, which means all statements on the left and the right sides of the AND operator have to be true for the whole expression to be true. See you again for the next video.